In this demonstration, I'm going to show how to use Proteus in the X-band, and for the purposes of the demonstration, I've created a C library that generates various types of CW signal. In terms of frequency, I could adjust the amplitude on the fly, I could adjust the pulse shape, but for the purposes of demonstration and simplicity, I'm just increasing the frequency. So if I run the code now, and you have to wait a second while Python builds all its threads up, and then it starts to generate the sound waves. And there you can see I'm streaming and I'm increasing the frequency as we go along. And then if you have a look at the spectrum analyzer, which is tuned to 10 gigahertz, you can see there's a CW signal there. Now the next thing that I can do is adjust my code slightly, so I generate random frequencies. And then I run it again, and on the spectrum analyzer the frequencies are jumping pretty fast, so it's hard for a sweeping spectrum analyzer to pick them up. It needs to be more a real-time spectrum analyzer. But if I go over to the scope, you can see the different sine waves jump into life there. So fast frequency signal switching, X-band transmissions, the ability to change frequency, amplitude, pulse shape, all on the fly using the 6 gigasample per second transfer rate that a Proteus can do, is certainly a good tool if you're interested in radar development.